Good morning, mister. So now I will explain my digital counter where I'm using 7 segments. But before we get into the process, let me introduce myself. My name is Luh Putu Indah Juliantari with name 24150911041 from Class 1 Denpasar. So, before we get into the process, we need to add some ICs. Here I've been to add ICs that we need to build the circuit. Okay, for the first circuit, I will add the JK flip-flop. I will add 4 JK flip-flop here. Then we need to rotate it to X minor. Okay. Okay, I will just copy this. Okay, we add here. Sorry. We put for JK flip-flop. Okay. But don't forget to rotate it to X minor. Okay, after that, I will put 7 segment on the top here. And then I add the logic probe. This position. Okay, done. And then I will add the named gate here. I will put here. And I also will rotate it to X minor. Okay, next we will add the power for the power supply. I will put it here. And then the last I will add the clock. Okay, the function of the clock is to ensure that the input operates automatically. So I'm use clock. And I also rotate it to X minor. Okay, after all the ICs have ICs, you just need to connect it each other. Okay, you need to connect the clock into a key. Okay, next, after that, don't forget to connect the first input of the NAND gate into a key also. And then we connect the key into a logic probe. And then from the logic probe, you need to connect it to 7 segment display. Then all the output connect to logic probe. Okay. Okay. After all connected, we will connect this to power supply. Here. So we connect 4 GK flip-flop into a power supply. Okay. And then the second input of the NAND gate, we will connect it to the third logic probe here. And then the output of the NAND gate, I will connect to the 4 GK flip-flop. Okay. So the logic probe is used to indicate that the value of the logic state whether it is high or low after we run the simulation, right? The value will be here, and then the output from the NAND gate is connected here, and then the last step, you just need to connect it into the output of the NAND gate. Okay, finally we just need to connect the clock into a clock. So the clock function is to ensure that the input operates automatically, and then we will check the circuits. We will run the simulation. Okay, we can see this is the result of the first circuit. So for the second circuit, we can just copy the first circuit, okay, like this, and then I will copy to clipper, and I will to paste here beside the first circuit. Okay, before I will remove the clock from the second circuit with delete object, and then you just need to connect the clock from the second circuit into output of the NAND gate. So the clock output from the second circuit is connected to the NAND gate with the output from the NAND gate, allowing it to reset or count automatically. Okay, and then I will repeat to put clock. Okay, that's the two circuit of my digital counter, and then we need to check it. I will run the simulation. Okay, here we can see the result of the simulation, where when it reaches to number 9, it will reset back to 0. So this is the function of the NAND gate, is to reset it back to 0 for the reset process. Okay, if you want to play it faster, you can reset here. Okay, before you reset, you have to stop the simulation. Okay, and then I will make it faster. Okay, I think that's all about my video. Thank you for watching, mister, and I'm sorry if I made any mistakes or if there are any shortcomings, and thank you. Salam Harmony.